Okay, so let's continue the system design. And last session we talked about how we can scale our database. What are the different way to scale database horizontally, vertically, and what are the different kind of techniques where which kind of algorithm the way you are distributing data into the different databases. Range based strategy, column based strategy, hash based strategy, directory based strategy, consistency. We discuss all the approaches and what are the advantage, what are the disadvantage. So once you are scaling your data, that means you are managing a large amount of data, then we discuss we can not use the only single database but use the set of database, and this database are located on different region, different places. Okay, so the one more challenges we observe whenever you are using the database scaling. Okay, and here if you are horizontally adding more database server, more database server, more database server, so what happened, your application load balancer are distributing load across maybe this, some requests go to 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 this. So your user traffics are going to distributed in the different database. It's okay and fine, but the failure scenario, what happened if this server somehow crashed or down or restarted and any request come here, you are not able to serve. Even your applications database is scale, but you are not make sure you are your request is available for every user. Yeah, this is the fine, at least some others requests are still going to serve by this database, it's okay. But what happened the actual the particular set of customers, now you can say your system is not available because those information whatever is stored here are not accessible. And what happened, somehow this database is crashed and you are not able to recover the data. So the chances are that whatever the data is stored in this database, you are lose. This is not expected behavior of any application. Customer data you cannot lose in anyhow. Let's example I discuss yesterday. Let's see, I created my Facebook account last 3 years back. Okay, everything working fine, and let's every day I'm login, I'm accessing my profile, watching profile video, everything's okay fine, and suddenly one day I am logging and say, hey, your user profile is not exist, invalid username password. Yeah, there is no profile exist because this data is crashed. So is it acceptable for any application? You can say, hey, your profile, can you create again new profile? This is really bad kind of situation. So how you can design a system that can ensure that if any database is crashed or destroyed or something happen, still you are provide the services to the customer. How it's possible? This is the possible. Whatever the data is storing, you can make the multiple copy. You can make the multiple copy of those data. If let's suppose data center is going to the crash or down something, still you have a 2 copy of the duplicate copy. So those concepts in the database designing known as a database replication, means the same copy of data you are putting in the different database. So in this way you are guarantee that any customer data I am not going to lose, because every data we receive from the customer, I am not storing only one database, I am restoring the couple of replica database. So generally whenever you are going to the set replica, you as a software designer or configurer going to decide, I am going to make a 3 copy of the same data, 4 copy, 5 copy, whatever you want. So at least minimum nowadays prefer size for any data replica, a duplicate copy of data, at least 3 copy you must maintain, and these 3 copy must be in the different region or different data center, not in the same region. What happen if any disaster happen, any earthquake happen, something disaster system happen, one particular regions of the earth can be collapsed. So at least one data center must be in a different region. So somehow some north part, south part, east part, west part of the earth, different continent, different country, you decide and replicate your data. So all the big player like Facebook, Instagram, LinkedIn are replicating is data in the different geographical locations, so that one geographical location, any disaster recovery happen, at least 1 or 2 copy of available in the different region. Once that region restore, you can again make a duplicate copy. So at least you have a 1 copy or 2 copy, you can make any number of copy for those data. So this is the things we are going to discuss. Database replications means how we are going to make duplicates of the data, making the many different copy of the original data. So let's talk. So this is the database replication. So database replication is a system design concept, involves maintaining the multiple copies of database in the different location. Simple meaning of database replication means you are putting maintaining multiple copies of the database in the different location. So this is the key point: multiple copy and different location, not in the same region, not in the same continent. Okay, so that you are ensure that you are handle disaster recovery, server failure, database crashed. So this database replication generally ensure your data availability. Whatever the situation happen, your data is available. Maybe couple of delay, but your data must be available. They are not going to lost. And even now, if your multiple database you created, multiple database created, right? And different requests going on. Even one database crashed, you know already duplicate copy available in this region. Thus this request can be redirected to the different region. At least there may be some latency issue, but you are still able to serve maybe from the specific customer, not the same region, but the different region. You can route the call and serve the user request. So somehow you are saying your system is very highly available, even data available, and always highly available for the every customer, not the specific customer. So in this way you can see your application performance also be improved, and also you are getting customer reliability. You are ensuring that customer data is not going to lost. This is the basics of database replications. So whenever you are designing system and you are scaling your database scaling is one of the good concept, but apart from the database scaling, that means you are adding more database server. It's good to handle large data traffic, but at the same time you ensure that you are not losing any data if database going to crash. So for those, how we are ensuring database replication means you are putting multiple copy of the data in the different location. So let's what the more kind of a benefits why this we need a database replication. Already we discussed improve the data availability. Data remains accessible even the event of failure or disaster. Any something disaster, earthquake, something happen on my server, on my data center, still our applications ensure that your data is available in the different locations. This way you can say increase the read performance. Why? Because now we are the same data you are putting the different region. So same copy of the northern region, same southern region, same eastern region. So whatever the user request come, they are going to the nearest location. They are going to the nearest location. They are going to the nearest location because each location you have a couple of copy. So this database replication increase the data read performance. Okay. And enhance the reliability. This way, whenever you talk to the customer, client, customers are getting reliable because data is preserved in the case of hardware failure or software failure. Let's not a disaster happen. If our database hard disk something crashed, our hardware failure happen. Still, you know, with same copy of data already had a different region, different location, I can get them. In this way, you are ensuring that customer, your data is always preserved, even hardware failure, even software failure, even system crash, even some disaster happen, some physical damage, some earthquake happen. Still, your data is preserved by the systems. And this support the scalability surely because you are scaling, adding more replica. If your system is growing, your system reachability in the different locations, the different location you can make multiple copy to the nearest data center. In this way you can reduce the latency and your system is so available because you are making multiple copying and storing in the different places. Already discussed meet the disaster recovery requirement. Any kind of disaster happen, ensuring that our data is available somehow at the remote locations. So these are the things you are get benefits whenever while database scaling and data replication. So both things you have to take care while database designing, scaling data, multiple data server, and the same time database replication, the data making multiple copy in the different locations. So whenever going to talk detailed kind of database replications, so these are some basic terms and concepts we are going to talk. Whenever talk multiple copies, so there is a one would be the primary database, one with the secondary database. So here primary database known as a master and secondary database known as a slave. So these are terminology masters and slaves. So whatever the generally in this way we are designing master database and the slave database. This is the master and this is the slave. So anybody, let's now think whatever the right operation I'm going to store data in the database. So we are not going to, customers or applications are not going to store in the two places because you say I am giving the 3 copy, so they are not going to replicate in the 3 copy. No. So what the logic here, we are just say, hey, the right operation will only go to the master database. So right go to the master database and master know ki these are the my set of secondary database. The internally lots of technology have available. They are sync this data to the here, they are sync data to the here. So that is known as a master slave architecture as well as. So here say कि master database accept the write request and send changes to the replica. And what the replica say? Replica means slave receive the changes from the primary database and apply to its own copy of the data. And so all the slaves replica channels establish communication between the primary database and its replica. So whatever the primary database available, the primary database is going to send notification or copy all the changes from the master data to table to these all three replica. That is, we have defined three data sets. The one data is written by the master copy. The same data are replicate by the using the replication channel in the all is the slave nodes or secondary node. So these are the basic concepts we are going to talk. Master DB or slave DB sometime, primary DB, secondary DB. These are the terminologies and the communication channel, how data are sync between the master to the slave. So with the help of this terminology, these are the key kind of types of database replications you can choose. These three, maybe master slave replication, master replication, and peer-to-peer replication. So these are the three different kind of types of database replication strategy you have. So let's talk one by one. What do you mean by master slave replication? What do you mean by master, and what do you mean by peer-to-peer? Okay, so these concept we should be clear while database replication, because you are going to put the multiple copy. This is the one, my file is one data. You have to put the multiple copy. So what are the way you are going to the copy here? Who is going to the copy? Where user going to responsible? Who is going to responsible? What are the different techniques? So this technique known as a database replication, and these are the three basic architecture behind the database replication: master to master, master to slave, or peer to peer. Let's one by one. So as clear, master and slave replication, it is very simple. That means key one is the primary database, that is the master database, access write request, and one or more secondary database, that is slaves, replicates the data from the master. So here basic concepts, we have a one master database and couple of, you can say, couple of your secondary database. So here all the write operation go to the master database only. So master database read the write operation, it's done. Now master responsibility, hey, they are going to replicate same data here, same data here, same data here. So whatever the replication factor 3, show master copy data are copied 3 times in the 3 secondary database. And this slave, then what slave do? Slave can use for the read only query, free up the master to handle write request. So now master is very free to request the write request from any region, but this the replica are ready to any read request come, get query comes, find query come, and these replica are stored in the different geographical locations. So all the users, whatever the location come, nearest replica database is responsible to returning the response. So our read is very fast, because now read available nearest the user and write is taken care by only one. So this is the master slave replication strategy or architectures. And if you talk about which kind of this database vendor, already good part in the system designing, whatever the concept we are going to understand, already your database provider or third party tools available, just we have to use. So if we want master slave replication. If I am using the MySQL or Postgres or Oracle or Microsoft SQL, they are already provide this master slave replication facility. Just you configure your database and configure, install multiple secondary database and set, hey, this is the master, this take the write operation, and this is the channel, they are communicate to the all other. These are just way of configuration, nothing else we have to do. We are not going to write code, just we have to configure, install database in such a fashion that, hey, these are the primary database, these are the set of secondary database, and this is the way our syncing happen between the master to slaves. And if you talk, such replication is generally if you use an application like your web server or any application server, or where the high traffic read like e-commerce websites. So whatever the where high read, generally you are going to the master slave replication. If you talk about the Amazons are using, Googles are using, Facebook using, Twitter using, eBay, these are the big player already using this master slave replication to ensuring that data reliability, data availability. So let's talk about the next master. So this is the master replication strategy. What say that is the many primary database, means now you have a multiple database, database 1, database 2 and database 3, database 4, all are the primary. This is the primary, this is the primary, this is the primary, this is the primary, except write request, each master replicate data to the other master. So anyone, let's keep this server receive the write request, this, okay, I am received this write request, I am going to replicate in other masters as well. As if might be they can also read the write request, they can write master here and replicate the same data in the different our master. So here trying to every database server is the master, they are ready to receive read request and write request, everything, because each are the master, are the primary database. And in this setup, generally we provide the highly available and fault tolerance. In case of master taken one fail, still we have a set of master available. So in the first scenario, what happened in the master slave, if a master is down, you are not able to you can say read write operation go again, we have to replicate the master, duplicate master. So that now here each master, that means any location, any places, write operation come or read operation come, your system is aware, your all masters are up to dated, all masters are synced to each other. And if you talk such kind of a database already, again this master replication already supported by Oracle database, MySQL Server database, IBM 2 and Postgres. If you want to master replication strategy, then you can use this database and just configure. And if for the applications which generally use this master replication, all the financial institution, banking, trading platform, real-time analytics, so where your data is very sophisticated and you don't want any kind of data lost or any property loss, something data and consistency problem, no. So all the financial institution are using this master to master replication, because nowadays lots of financial institutions have, lots of banking systems have, and they have different region, different center. And as a one customer today, I can visit one branch and later I can also visit another branch, different locations. If my profiles is not available in the different location, is it very hard for the banking to serve the services. Due to the I am using my ATM, I can use the same ATM in one location, go to another location, go to another location, and even across the locations our profiles, our data available, because they are using the concept of master to master replication. Every location, whatever the data have, they are a master, and every location have all the data, duplicate copy available. And if you talk good players, Goldman's, JP Morgan's, and these are the American Express, all are the big financial institutions are ensuring data reliability using the master to master replication factor. And third schema about the peer-to-peer replication. Here means ki all the data, whatever the data you scale, let's say you is designing, you are scale your 5 or 10 databases. Okay, so you can say all are the equals. So in this schema, say there is no any concept of the master data or secondary data. All are the equals capability, not like a peer. So due to this peer-to-peer replication, each replicates, peer replicates to other peers. If all are the equal, means they can use the read and they can use the write, both operation, and they are replicates all other data in other databases. So this setup is generally provide very high availability, scalability, and fault tolerant facility. Peer can take one if other failover happen. So in this case, peer-to-peer replication, we are not talking any master, we are not talking any slave. See, all the database are the same level and same capability. Just we scale our data and we are putting the same data in the multiple copy of the different location. So let's talk about the, for this scenario, peer-to-peer applications, Apache Cassandra is very open source and nowadays use, MongoDB use, our Couchbase are using this technology, and is similarly Amazon's also provide the Aurora database where you are going to use the peer-to-peer application you can configure. And if you talk the whatever the big data analytics applications are, IoT data processing, are real-time analytics, are wherever you want to, your database is more and more scalable. So in those scenario, peer-to-peer applications are used, and these are the very good example. Netflix are using the peer-to-peer, Airbnb, Uber, LinkedIn, lots of bigger players are nowadays using peer-to-peer replications, right? So here, whenever I was studying this, might be you have a questions, peer-to-peer and master-to-master. What are the differences? In the master, all the database also look like a master. They are performing all operations. Similarly, peer-to-peer. So what the benefits where you are using this, right? What are the so let's talk so that you can clear differences between master-to-master and peer-to-peer. Sometime it will be confused for initially, but once you understand, so let's start. So master to master and peer to peer. In master to master application, each master is aware of the other master and replicates data to them specifically. So here design say, if let's this is the master data, one master, and corresponding we have a 3-4 masters. Okay, all are master. So this one master know this is my 3 master I have to replicate. Similarly, this master know I have a 3 replica, 3 my master. Similarly, this also know this is my 3 replica masters. This master also know if any I receive data, I have to replicate here, here, and here. So this is the means each master know how many number of master I have to replicate my copy. This is the inside the master to master. But what happened in the peer to peer? Each peer is not aware to the other peer and replicate data to the any other peer available. So what here say lots of database available, whatever the number of database available, he know ki I have to replication factor 5, I have to go to write in the 5 database. Maybe they can write in a different 5, maybe they can write a different 5. So here they know the only replication factor 3. So I have to make the 3 copy, whatever the nearest my peer, whatever the peer want to, they find the maybe some IPs and they are going to write. So here the peer to peer, one is not aware all my peers, maybe whatever the nearest I'm going to write, they are going to write the nearest, they are going to write the nearest. So in this way peer to peer communications or replications happen. So here majorly if you talk the different properties of the master to master and master to peer to peer. So master to master and peer to both provide kind of a high level of scalability. Availability, both provide a very high level of availability. Consistency here is the differences. So if you want to ensure that our consistency cannot be loose, like financial institution, so they are going to the master to master slave strategy, and peer to peer might be is the very low, or can sometime we can compromise our consistency because every pair not ensure that they are going to replicate the each peers. So this is the major differences between the master to master and peer to peer, where sometime you want to compromise your consistency, then it's okay peer to peer. But in the banking system, financial domain, you cannot compromise data. You must go to the master to master replication factor. And similarly, flexibility. Here might be you have due to the master to master configuration, there is the complexity is the very high. So here you can say very flexibility is the low, but here peer to peer you have lots of flexibility. You can add more and more server, more different database, different schema, different profiles, right? So there is a schema flexibility is very high. And latency both because whenever you are going to replicating, copying data from one location, there is some latency happen because you are replicating data from one location, one region to another regions. But if you talk about the some other not important but some